Welcome everyone. In this video, I will be covering section 13.4, motion in space, velocity and acceleration, the concept behind velocity and acceleration. How do you find the velocity, speed, and acceleration of a particle that moves along a space curve? If r of t is the position vector of the particle on the space curve, then the velocity vector v of t is just like the regular definition of velocity, which is the derivative of the position vector, so which is r prime t. The speed is given by, which is the absolute, the length of the velocity vector is given by absolute v of t, length of the vector v of t. And the acceleration a of t is the second derivative of the position vector, or the derivative of the velocity vector, or it is the second derivative of the position vector. It's kind of similar to the single variable problems. So a problem here in this particular problem, problem number 5 and 11 are done in my video. Also 21 are done in the video section for the set of videos for section 13.4. So refer to these problems. Section 13.4 for problem number 5, 11, and 21. And even one more problem is done. So now let's see a different concept about projectile motion of a particle. Projectile motion. A projectile is fired with an angle of elevation alpha and an initial velocity v sub 0. It's an initial velocity, meaning that velocity at time t equal to 0. So if you have to refer this to this figure 6. Assume that the air resistance is negligible. Only external forces due to gravity. Find the position r of t of the projectile. What value of alpha maximizes the range, which is the horizontal distance traveled? So let's keep this figure as the base. The assumptions that we are doing here is we are setting up the axis so that, namely x-axis and the y-axis, so that the projectile starts at the origin. So the projectile starts at the origin. So we are setting up the x and y axis so that the projectile starts at the origin. And one more thing that is given in the problem is that initial velocity is v sub 0. So the initial velocity is v at 0 is v sub 0, which is given like that. In fact, they are using the lowercase. Let's take the lowercase notation. Find the position function r of t. The question is, what is r of t? And what value of alpha maximizes the horizontal distance? What is the value of the elevation alpha? That maximizes the horizontal distance. The horizontal distance maximizes the range. The range here is taken as d. So we have to find out what is that value of alpha that maximizes d. this is what the question is. Uh, Now we are assuming x and y axis and the projectile is shown in pink color. And then the initial velocity at that point is v sub 0, at the origin is 0. And then we are going to find out what alpha is. First, we have to find out also the position vector r of t, where p is any point in this projectile. So having given this information, it's also given in the problem that the resistance is negligible, the only external force due to gravity. So if you look at this sentence, the only external force is due to gravity. That is our starting point. The external force is due to gravity. That is the only force. So we have to set up the second equation that we know. Force equal to mass times acceleration. And because the external force is only due to gravity, if I assume g to be the magnitude of the acceleration, and then acceleration is the force is acting downward, so it is going to be downward j. So downward means negative y-axis. For negative y-axis, we have to associate um, the j vector with a negative sign. If it is upward, then it is positive j. If it is downward, it is negative j. Because the force due to gravity acts downwards. So we have ma equal to negative mgj. So if I cancel m on both sides, here the assumption is also make a note that g is absolute value of the acceleration, which is equal to 9.8 meters per second square. So ma is negative mgj. If I cancel out the m on both sides or divide both sides by m, then this gives us a equal to acceleration is negative gj. When you say acceleration, acceleration at time t equal to negative gj. Acceleration is the derivative of the velocity. So derivative of the velocity equal to negative g times j. If I integrate, I will get v of t. V of t is integral of negative g j dt, which is negative g t plus j, of course, plus the constant of integration, which is a constant vector here. So v of t being a vector, the v of t, which is equal to negative gtj plus a constant vector. Now, having known the velocity vector, and we are also given the initial velocity equal to v sub 0. We will substitute that in this relation to get the constant c. Whenever you are given an initial condition, you can find out the constant, right? Constant of integration here. So I'm going to substitute when t equal to 0, initial velocity v at 0 is given to be v of 0. This is given in the problem. So substitute t equal to 0 in step 2. So we get v sub 0 is v0 equal to negative g times 0 j plus c. This gives us the vector c equal to v sub 0. So substitute that in 2, you get v of t becomes negative g t j plus c equal to v sub 0. So call it step 3. V of t, also we are given this being the initial velocity if you look at the picture, the initial velocity v of 0 is making an angle of alpha. So if you divide the velocity into horizontal and vertical components, so you know that if this is v0, or I call it magnitude of the velocity, initial velocity equal to absolute of v0, and if this angle is alpha, then you know that this is horizontal component and this is the vertical component. X equal to V0 cosine alpha, absolute value of V0 cosine alpha. Y, the vertical component, is the length of the velocity, initial velocity, sine alpha. So these are the horizontal and the vertical components. So V of t can be written as negative GTJ plus the velocity vector v0, the initial velocity can be written as the length of the vector times cosine alpha I, which is x component, then length of the vector times sine alpha j. Here absolute v0 equal to v0. Right? So this is the initial velocity. And that is equal to v0 cosine alpha. The magnitude of the initial velocity is taken as lowercase v sub 0. So we have, there are two terms involving j here. So if we combine those, you get v0 sine alpha minus gt j plus v0 cosine alpha I. That is v at t. Now if you integrate v of t, you can get r of t. So r of t is integral of v of t dt. If I integrate this expression, we will get v0 sine alpha t minus g t square over 2 j plus v0 cosine alpha t I. So we get two expressions, one for I, the other one for j. So that is r of t. So that is the position vector. So position vector r of t. In fact, we should also add a constant of integration here, c. And we can use the fact that the particle starts at the origin. The particle starts at the origin. That means the position of the particle at the origin is 0. So it is r of 0 equal to 0 vector. So it starts off at the origin. So in this result, in this 5, equation 5 for r of t, if I substitute t equal to 0, then 0 equal to r of 0, which will be everything involves t. So this is involving t, this is involving t. All those will become 0. Then this has a t as well, so that will become 0. So c actually becomes 0. So this is obtained by substituting uh, t equal to 0 in equation 5. You can prove constant t c equal to 0. Substituting the constant c equal to 0 into equation 5, we get r of t equal to v0 sine alpha t minus g t square over 2 j plus v0 cosine alpha t I plus 0, 0 vector. So this is the position vector. It answers one part of the question. Next part, we are asked to find out what is that value of alpha that maximizes the horizontal range, right? So next part is to find out This is, let's call it step 3, is to find out alpha. Find alpha that maximizes the distance d. Okay. So when we look for the horizontal distance, that is obtained by setting the y coordinate equal to 0, right? To find out the horizontal distance, x should be set to d and y should be set to 0. If you look at the projectile, so at this point it is, the distance is d and the y coordinate is 0. So it is horizontal distance is d, and it is hitting the ground, so the vertical distance is 0. So d, the y equal to 0, you have to set the y coordinate to 0. So what is the y coordinate here? So r of t actually tells us, r of t, when you say it is r of t in this step, so this part is the x coordinate, that part is the x coordinate, and this part is the y coordinate, y component. So x equal to d, and we have to set the y coordinate to 0 to find out the time t in order for the projectile to drops to the ground. So setting y equal to 0, we get v0 sine alpha t minus gt square over 2 equal to 0. In both terms, t is common, so take the t common factor out. Then it is v0 sine alpha minus gt over 2 equal to 0. So this gives us two values of t. The first value of t, which is t equal to 0, can be disregarded, but it is the initial position. So the second value of t, so it is, second value is obtained by v sine alpha minus setting gt over t to 0. So if you solve for t, the gt over 2 equal to v0 sine alpha. So if you isolate t, it is 2 over g v0 sine alpha. So this is the time t, that many seconds, for the projectile to reach the distance x. So substituting this into x, substituting the above t, the t value into x. What is x? X equal to actually v0 cosine alpha from equation 6, cosine alpha t. Then you substitute that t, v0 cosine alpha times t, which is 2 over g v0 sine alpha. So here you have 2 um, sine alpha, cosine alpha, so which can be taken out. So which is 2 sine alpha, cosine alpha times v0 square divided by g. In other words, it's v0 square times sine of 2 alpha divided by g. So you have to see what maximizes. So here x is maximum, or that the horizontal distance d, which is x, is maximum when sine alpha, sine 2 alpha is the maximum. So what is the maximum value of a sine function is equal to 1, which means 2 alpha must be equal to pi by 2, or alpha equal to pi by 4, or 45 degrees, 45 degrees. So what it tells us is d has the maximum value, the horizontal distance, the horizontal distance of the projectile is the maximum, when alpha equal to 45 degrees. In other words, when the projectile makes an angle of 45 degrees, then the horizontal distance would be the maximum. There is a problem. So you have two questions here. One is to find out the position vector. So we started off with the force, with the force condition. Force is only, the external force is only due to gravity. We took that relation, and then we found out the acceleration. From the acceleration, we found out integrating, we found out the velocity. Then integrating the velocity, we found out the position vector. That was the first part. And then the second part is to find out the alpha, the angle of elevation, angle of the projectile to reach the maximum horizontal distance. So that turned out to be 45 degrees. So based on this particular concept, we have a problem, which is problem number 25. Yes, problem number 25, which you can try from my video. There is a video in the section videos, you will find this problem. Please take a look at this. And we will try one problem here, problem number 7, now, which explains the concept that we defined in the beginning of this section, how to find out the velocity and acceleration. So find the velocity, acceleration, and the speed of a particle with a given position function, sketch the path of the particle, and draw the velocity and acceleration vectors for the specified value of t. So the problem number 5 is done in the video section for 13.4. Now I'll show you another problem here, which is similar to that problem, which is problem number 7. Problem number 7 is the same thing. You are going to find out the velocity and acceleration. So find the velocity, acceleration, and speed of the particle with a given position function. Sketch the path of the particle and draw the velocity and acceleration vectors for the specified value of t. The problem that we have chosen is r of t equal to ti plus t squared j plus 2k at t equal to 1. So you have one more problem to refer to for this part, which is problem number 5, which is done in the videos for section 13.4. So in this problem, we are given r of t, and then we are also given t equal to 1. So the first step is to find out at t equal to 1, what is that point? So let's find out the point, what we are referring to as a point. Find the point corresponding to t equal to 1, when t equal to 1. So r of 1 would become 1i plus 1 square j plus 2k. So the point that we consider here is the vector r of t is 1, 1, 2, but the point, in terms of point, it is 1, comma 1, comma 2, x coordinate, y coordinate, and z coordinate. So this is your first step. Then we are going to find out the velocity of this r of t. So r prime t. So take this one and find out the velocity. This step 2. R prime t is the derivative of each component. So it's 1i plus 2tj plus 0k. That's equal to 1i plus 2tj. Now you want to do velocity at t equal to 1. So velocity at t equal to 1. T equal to 1. Velocity at t equal to 1. which is 1i plus 2 times 1j. So it is 1 plus 2j. You can also write that as 1, 2, 0 in terms of three-dimensional. Then what is the next? We are going to do the acceleration. That is the acceleration at time t. Acceleration is the derivative of velocity. So we have to take this one and then differentiate each one of them, each component. That will be 0i plus 2j plus 0k. That is just 2j. Okay. So we got acceleration and acceleration at 1. So we are asked to find out everything at that instant t equal to 1. So we are substituting. We are replacing t with 1. So this will be 2j as well. So we found out velocity and acceleration at t equal to 1. Then we are also asked to find out the speed. Speed at time t is the length of the velocity. The length of the velocity, velocity is actually this one here. So velocity is this, 1i plus 2t. So it is square root of 1 square plus 2t square. The derivative of r is the velocity, right? So what we see here is the velocity. Hope you understand that part. So it is square root of 1 square plus 2t square, which is equal to square root of 1 plus 4t square. So that is the speed at time t. Then now we are going to connect all of this and also do the sketch. So if you look at r of t, step 4 is to sketch, right? So r of t is given to be ti plus t squared j plus 2k. So from here, we know that this is x of t, and this is y of t, and this is z of t. So you notice here, y is t square, but what is y equal to t square? So what is y, what is t though? T equal to x. So y equal to x square, right? Y is a parabola, vertical parabola, horizontal. Y equal to x square is an open upward parabola. But though it is open upward parabola, because of the fact that z equal to t, z equal to 2, so if you notice the z coordinate, it's equal to 2. Z equal to 2 is a horizontal plane, right? So it's a horizontal plane. Z equal to 2 is a horizontal plane. So we are looking at the open upward parabola in the plane z equal to 2. So r of t is actually a parabola in the horizontal plane, in the plane z equal to 2. So that is what r of t is, which is a space curve. Now, in this space curve, we are going to find out, we are going to sketch the velocity and acceleration at this point, at the point corresponding to t equal to 1. So at the point 1, 1, 2, which we mentioned earlier. So let's sketch this. So we are going to consider a parabola at a distance. The parabola is y equal to x squared, so which involves x-axis and the y-axis. So if you consider this only in the xy plane, in a two-dimensional plane, you will write this as x and y, then y equal to x squared will look like this. It's an open upward parabola. Imagine that we have here This is the negative y-axis, and this is positive y, and this is negative z, and this is negative x-axis. So we are in a three-dimensional plane, a three-dimensional coordinate system. So you're going to consider y equal to x squared, the parabola, in the plane z equal to 2. So it's kind of you have a parabola, and you're raising that parabola in the xy plane parabola to a distance, vertical distance of z equal to 2. So you have to lift up the parabola um, to a height z equal to 2. So I have a parabola which is drawn in the plane z equal to 2. So every point in that plane will have the z coordinate equal to 2. So I'm considering here the point corresponding to the value t equal to 1. T equal to 1 corresponds to the point 112. So you know how to graph that 112. So on the x-axis, you have to go 1 unit. On the y-axis, parallel to y-axis, you have to go 1 unit. Then you have to raise about 2 units. So I have a point here, which is 112. In that point, I have to draw the velocity vector and the acceleration vector, right? So this is the point I consider. Here I have to draw the velocity vector and the acceleration vector. So what is the velocity vector that we found out? Which is 1, 2, the z coordinate is 0. So at this point, 1, 1, 2, I have to consider the vector 1, comma 2. So 1, comma 2, if you go in the coordinate plane, so it is 1, and then along the y-axis, you have to go 2. So if I consider the radius vector, this is the point 1, comma 2. On the x-axis, you have to go 1, and then along the y direction, you have to go 2. Then the position vector is this vector from the origin. So what you have to do, your velocity should start at the point 112, and it should be parallel to this radius vector. So let me call this one as OQ. It should be parallel to the velocity vector, direction of the velocity vector 1, 2. So the direction vector of velocity is 1, 2. So it has to be parallel to that. So that is your vector, velocity vector, whose value is, which is v at 1. Velocity vector at t equal to 1. Now, what is the acceleration vector we found out? Acceleration vector that we found out was 2j. If I draw that individually on this graph, 2j is a vector along the y-axis, along the j direction, through units of 2. So this is 2. So it is along the y direction. So my position vector would be this vector, which is, let me call it like OR. So OR is the acceleration vector. So the direction of the acceleration, which is 2j. So your vector here should start at the point z112, and it should be parallel to the vector OR, the acceleration vector. So it will be like this. So which is nothing but a at 1. So you got the point, you have drawn the velocity vector, you have drawn the acceleration vector. Everything corresponds to the parameter t equal to 1. The parameter t equal to 1 corresponds to the point 112 on the space curve. And velocity at 1 is the vector 1, comma 2 in that direction. And then the acceleration vector at 1 is 2j. And then we got the parabola y equal to x squared in the plane z equal to 2. Parabola in this plane, that's why it's lifted up at a distance 2 units. Hope this video helps.